The people didn't get bigger, the spacing changed. For most liquids, warming makes molecules move more energetically, increasing their average separation. So the volume expands. Is space cold because the particles aren't moving much? You're very close. Temperature is related to the average energy of particles. The reason space is strange is that there are so few particles. Imagine two situations: a room with 1 million energetic particles, room B with 10 energetic particles. Both particles may individually be moving fast, but room B contains almost no heat overall because there are so few particles. Okay, that makes sense. That's why when you're cold, you get together or you try to like move so that you can heat up, because that's basically like you're like shaking your molecules, and then that's causing it to heat up. Which shaking is really what? A vibration. So it's a vibration and an energy that is allowing for heat or warmth to get the individual molecules moving. So more movement, more heat. Less movement, cold. That's why astronauts don't experience space the same way you'd experience being in a freezer. Space isn't full of cold air, it's mostly empty. How can the sun heat us through cold space? Right. This is one of the biggest misconceptions people have. Heat can travel three ways: conduction, touching, convection, moving fluid or air, radiation, light. The sun heats Earth through radiation. Oh, no air is required. The sun emits enormous amounts of electromagnetic radiation. Some of that reaches Earth and is absorbed by land, water, and atmosphere. The sun, the same reason you can feel heat from a campfire without touching it, is the reason Earth can receive heat from the sun. So the same way you said there's a certain chemical process, but really you're saying to allow for that process to occur, there may be a heating process. And so that's why when the oil was inside of the earth, was it being heated or cooled? Like, how is it exactly being stored? And then we know that there's almost like pretty much a sun nearly inside of the earth. Was that important in the preservation of the oil, or what? Or was that the reason why it was still, like, was that the reason why it was still an oil? Or is the absence of the heat the reason why, like, because it was so far from the core of the earth, so it wasn't being heated up, is that the reason why it was able to be liquid? So when it comes here, we heat it up to turn it into a gas. So again, that's what I'm saying. And right now, all the elements we're talking about, they're right now, for example, being exposed to the earth. Before we found it in the ground. So if we were to store these chemicals in like a dark space, for example, or of a certain coolness, as though like basically simulate the conditions of the oil being underground for the gas, so that the gas can form back into how it was in the ground, which was as a liquid, and then we could just use it again. Is the sun actually there or just light? The sun is physically there. You aren't seeing a projection. Really? You're seeing light that left the sun about 8 minutes ago. The actual star exists roughly 93 million miles away. The light is simply the the light is simply the messenger carrying information from it. What light? The sun? The actual star exists. The light is, okay. Isn't space hotter in some places? Absolutely. Space is cold is an oversimplification. Temperature depends on location. For example, a spacecraft in direct sunlight can become extremely hot. The shaded side can become extremely cold. Near stars, space can be blisteringly hot because of intense radiation. Far from stars, it can be incredibly cold. Why isn't the atmosphere transparent? What did they say about the light? What do you mean the light is simply the messenger carrying information from it? What information? Light information in the sun from a star. Well, the sun is like a star. That's a frequency and energy. So, okay. A spacecraft in direct sunlight can become extremely hot. It's 222. What if the aliens are communicating with us through the sun? Because it's like light information. So they're saying if the light energy is encoded, are we actually receiving, do we receive messages from the aliens or something? Near stars, space can be blisteringly hot because of intense rain. Okay, blah, blah, blah. Far from stars, it can be incredibly cold. Why isn't the atmosphere transparent to infrared? Exactly. This is the heart of the greenhouse effect. The atmosphere is mostly nitrogen and oxygen. Those molecules don't absorb much infrared radiation, but some molecules do. Water vapor, carbon dioxide. Wait, those molecules don't absorb much infrared radiation. Okay, but some molecules do, like water vapor, carbon dioxide, methane. These molecules have shapes that allow them to vibrate and rotate when infrared radiation hits them. Wow. Think of infrared light as someone pushing a swing. Certain molecules are pushed so that they catch that push. Yeah. Nitrogen and oxygen mostly don't. CO2 and water vapor do. So infrared radiation gets absorbed by those molecules instead of passing straight through. And I think the deepest question hiding underneath all of this is one you've been circling around. If energy is always moving around and matter isn't destroyed, then what exactly is global warming? The answer is that it's not about creating more matter. It's about changing where energy is stored and how quickly energy can leave the Earth system. The atmosphere isn't a solid lid. It's more like a partial transparent blanket. Energy still escapes to space, but not quite as quickly. The debate is mostly about how much the slowdown. Is there a way for us to increase is there any way for us to increase the energy escaping? Because wait, are you saying that essentially it's like a pressure that's building up? And it's like it needs to be released into space. Which also you're saying it's like a blanket. So you're saying like the firmament, like there's an invisible, I mean they call it what, like the electromagnetic grid or something like that. So that's real. There's really like a thing preventing, well, apparently it's not preventing us from leaving, but you're saying it's preventing, this invisible field is preventing gas from leaving because of energy. I don't get that. Why can humans leave, but the gas cannot?